Hello, dear students. Today we have Proposition 33 of Book 1. Straight lines which join parallel and equal straight lines at the extremities and on the same side are themselves parallel and equal to one another. Really. So here we have the given. Two straight lines. This line is both equal to this line and parallel to this line. It's given that the two lines are equal and parallel. This is a symbol often used for parallel. Okay, so this line is parallel to this line, and this line is equal to this line. What we want to show is that when those two endpoints are joined on the same side, not crisscrossed, but when it's on the same side, right side, left side, let's join the 2 points on the right side. And let's join the 2 points on the left side. Point, point, let's just join them with a straight line. Thus, it is required to prove that having done that, I just, per accident, made this line both equal to this line and parallel. This is parallel to this, okay? Let's prove that. You don't want to say, wow, there you go, it's clearly parallel and it's clearly equal. Look, no. It appeals to the imagination, but we also want to appeal to the intellect. So the intellect says, prove it. So we're going to prove it. We're going to join these 2 points. This is called the transversal, I don't know what it's called. Something like that, transversal axis. Okay? So it is required now to show that this is equal to this and this is parallel to this. Let's go with what we know. We're going to use our bag of tricks here. We're going to use side angle side, and we're going to use that when lines are parallel and another line lands on top of it, it creates alternate angles equal to one another. So it's a pretty easy problem. So here you have two parallel lines. Line falling on this, it creates alternate angles. Make sure I'm doing this right. Yeah, alternate angles. I don't want to do that with, I want to do it with an opposing color. Equal to one another, okay? So we know that this is equal to this because this line is parallel to this line and this is falling upon it, creating alternate angles equal to one another. Great, so igualdad. Now we're just going to use side angle side. We have two triangles, two sides equal two sides, and the angle of the container equal, the base equal to the base. Here we go. Triangle, triangle. This, and this are equal to this, and this. That is, so look, this is equal to this is equal to itself, and this angle is equal to this angle. Side, angle, side. Side, angle, side. Therefore, the base is equal to the base. The triangle is equal to the triangle, and the remaining angles are equal. So let's do that. Let's see what we have for remaining angles. Okay? So this one is going to be equal, because it's opposing the opposite sides are equal. So the angles, which are subtended by opposite sides, are going to be equal. So this angle is going to be equal to this angle. Now look what we have. We have two lines with a line falling upon them, and here these are alternate angles. And they're equal. And we know from previous prop that if you have a straight line falling upon a straight line, creating alternate angles equal to one another, those two straight lines are indeed parallel with each other, okay? So this is parallel to this, which was set out to be proven, that when you join these two equal and parallel lines at the extremities on the same side, that those lines which join those extremities are both equal to each other, we proved that, and parallel to each other, which we proved, okay? And so that's going to happen always, universally. Therefore, we know that if there be two equal and parallel straight lines and their points be joined by straight lines, their extremities be joined by straight lines on the same side, those two lines themselves will be equal and parallel with each other. Quod erat demonstrandum. Thank you. Bye-bye.